Hey, everyone. It's so nice to see everyone again, virtually, at least, hopefully in person sometime soon. And I thank the HDF group for inviting me to speak. So this is a slight variation of the talk that I gave at the European Hug and at the ESIP conference over the summer. And I'm going to be talking a lot about cloud support that we've recently added, as well as our big upgrade to 110.7 HDF5. And so we'll also show a demo that integrates cloud workflows with SWMR and with VDS, and that will be pretty cool. So hopefully that will work. Always demos are a little iffy with talks, so hopefully that's going to work. So I've been at MathWorks for about 8 years now, and it's really funny because there's so many national labs that are always at these talks, and it's great to hear all the research going on. And I didn't hear about HDF5 first at MathWorks. I actually heard about it first when I used to work for MIT Lincoln Lab. We were doing some simulations of satellite data, and the data we were storing it in HDF5 format. So that was my introduction. So big shout out to all the national labs for all the great work you're doing. And the team I work on at MathWorks supports audio, video, image, and scientific data. Whoops, excuse me. So we focus on HDF5 and of course NetCDF and with OpenDAP. So shout outs there to James at OpenDAP and Ed at Unidata. And we also support the image file formats, a bunch of them, but those are the big ones that we see there. So as well as audio and video, but of course I'm going to talk about the SCI formats today, particularly HDF5. So just a quick recap. Hopefully you guys all know this by now. Oh, and a quick trivia question. Hopefully everyone knows MATLAB stands for Matrix Laboratory. So it's really expanded a lot since it used to be just a simple interactive matrix calculator. So that's pretty cool. So in HDF5, in MATLAB, we have rich interfaces for HDF5 at the high level and low level. The high level, of course, is more for casual users. It's ease of use, makes it really great to read and write and explore HDF5 files super quick, but doesn't have as much functionality as a low-level interface, which also is much more extensive. So we recently redid our doc. So if anyone's using 21B, they might notice a difference in our HDF5 doc. So we have still have 7 high-level functions, and we redid the low-level pages so that they're more easily referenced back to the C API. So if you know the C API for HDF5 and for NetCDF for that matter, for a NetCDF interface, you will be okay with MATLAB, a low-level interface. So we have about 330 now low-level functions. We added about 30 for SWMR and VDS and some other things with 110.7. And the NetCDF interface is pretty rich as well. We also have a MATLAB only API that is not part of the HDF5 library, but it's stuff that we needed to add for users to have better experience and to query more, give more control to the low-level library. So I want to talk about what we've been up to. A lot of you have seen this slide before, but it's an interesting story. So if we take a trip down memory lane, way back in 15A, it was one of the first things I did when I joined MathWorks is upgrade HDF5. So we used to be at old 186, and I did the 1812 upgrade. We also added reading support for dynamically loaded filters. You might hear me call them DLFs at some point, so it's the same thing. And during 15A, toward the end of around 2020, 2019, we tried to upgrade to 110.2. The upgrade went fine, except we found some pretty big performance regressions. Not so much in our interfaces, though there were some, but it was mostly in other teams at MathWorks that happened to use HDF5 internally. So we put that on hold because we had to sort that whole thing out. And then 20B, what we did was we added support to our HDF5 interface for accessing, writing, reading HDF5 data on the cloud. So we added support for both read and write on S3 and Azure. Hadoop for now is read only. We're still working out some write issues with that. And we enabled it for our entire interface, both the high level and low level functions. So that's part of the demo that I'll show later. And then we still spent more time figuring out what to do with the performance regressions. The MathFile team, if anyone knows MathFiles, version 7.3 is based directly on HDF5, so that was part of the regressions. They are cloud enabled now. And then we attempted a 1.10.6 upgrade, working heavily with the HDF group, so thank you to them. And we still had regressions, but we devised a solution. And so the good news is MATLAB is finally now in 1.10. So we're at 1.10.7. We're eagerly awaiting the upcoming 1.10.8 release. We'll upgrade to that. And what did we do? We added new low-level functions. So not yet in our high-level interface, but in our low-level functions is a whole bunch of new functions for SWMR VDS, fine-tuning the metadata cache, and partial edge chunk, which I've heard about earlier in the conference, and I know some of our big customers were really interested in that. So what do we have to do? So this is just for any Linux geeks out there. It's interesting what we had to do. So we didn't want to disrupt the MATLAB and the existing team's performance at MathWorks. So for 21B, we're actually shipping 2 HDF5 binaries. So rest assured that the HDF5 interface is current on 1.10.7. The rest of MathWorks right now is using the old version. And how we did that was a whole bunch of Linux symbol versioning magic, which was actually really, really cool to learn. Okay, so I talked about that already. And again, a big thanks to the HDF group. So we're working with THG and some of the other internal MathWorks teams here on a solution so that we don't, this was interim only, we don't want to ship 2 versions of the library. Okay. So some functional details about what we added, again, about 30 new functions, SWMR VDS, etc. We also modified a bunch of existing functions to work with 1.10.7. The set lib verbounds is one probably most people know about, to accept the new high-low values to control the versioning of how the objects get created in the HDF5 file. And again, the cloud stuff that we added in 20B works with virtual data sets. So that is really, really cool. We tested that out. Now, we didn't do SWMR on the remote systems because of the POSIX compliant a factor that they have to have. So we haven't done really any testing with SWMR. I think one of the cloud providers might be POSIX compliant, I'm not sure, but that's still work that we can do. And I'll go, this is quick, but it's a bunch of it's all the new functions and the map to the HDF feature. So you might see those are very similar to the C API. So let's talk about what we did for cloud data access. So thanks again to the HDF group and for having the virtual file layer and the virtual file driver ability to write our own. We wrote our own VFD and we connected that with MathWorks and a pretty robust code base for working with the cloud providers. So we have callbacks to the HDF5 library, and then that passes the file descriptor. We pass that internally around. And that's how we were able to add support for read and write on Azure and read only on Hadoop. And I've seen a lot at ESIP and this Hug and the other Hug about Google Cloud Storage. So one of the things that we don't support is Google Cloud Storage, and I'd love to hear feedback if people are starting to want to store their data there as well. But of course, the big one being S3. So it's supported in high level and low level interfaces. Here's a little quick examples just using our high level interface. So an example on S3 on Azure. And since Hadoop is read only, it's just showing read and not writing. So we're hoping people not only test out SWMR and VDS with 21B, but also our cloud support. And here's a revised demo, and I give credit to our colleague, physicist / engineer Cedric, who made this demo. So I'm going to walk through it now because in the past talks I went really quickly right into it. So what are we doing here? So we're getting bathymetry data and we're slicing that up and putting source files on Amazon S3. Okay. At the next point, what we're doing is we're creating a virtual data set from that on Azure. Now, I don't know if anyone would have any workflow to do that, but we just wanted to do it as a proof of concept, okay? So then, to showcase SWMR working with the cloud and with VDS, we have simulation where it's simulating ocean waves and is using MATLAB parallel workers to write that data. So there's 3 separate sources, 3 separate files that are being written to that are SWMR enabled. And that is, we're using one reader to display just the 2D images of those as a simulation runs, but we're also doing the second reader. So there you go with the multiple readers, and we're overlaying the wave propagation model on top of the bathymetry that is being read from a VDS on Azure. So that was kind of a mouthful, but let me show the demo. Hopefully all will go well, and you guys will see what's going on here. So luckily, this should go fine. It's pre-recorded. Okay, so that's building up the slabs, building up the virtual data set. So we're going to display the virtual data set now. So this is reading from Azure, from the source files in S3. So we get the MATLAB workers about to start up to write the 3 files. And we're reading it 2 readers. So it's really cool. I'm hoping people are going to see here that they can do all sorts of really cool things now with the cloud and HDF5. And SWMR and VDS. So big shout out to Cedric for that demo. Let's go to the next slide. Let's talk about performance for a little bit. So, with a big jump from 1.8.12 to 1.10.7, which we don't want to ever get into this situation again where we do that big of a jump. We saw some improvements, which is really, really great. So big ones in H5 write and create. So that was really great. But again, so in our area, so this is separate from the other regressions that are happening with the other teams at MathWorks. So we saw some pretty substantial regressions with H5 info, and I've been and somebody mentioned this earlier. I think it was with the Apache drill talk that it's a lot of regressions with highly nested groups if they contain extremely small data sets, and also some regressions with compound data sets if they're heavily nested. So I've been working with Elena and the folks at THG to figure out a solution for that. I'm not sure yet if it's the same issue as our internal teams are running into, but we're doing ongoing work there to fix it. So in addition to optimizing H5 read, which we've known about some performance issues in the past, so we want to tackle that soon. And we're going to add more workflow, more real customer workflow tests to our test suite, so we get in pretty good shape testing everybody's models out. And for compatibility, a little caveat with that Linux tidbit I mentioned earlier is for Linux folks, if they have any filter plugins that they've previously built against HDF5. So there's always the issue with filter plugins, not an issue, but a caveat that really should be built against the version of HDF5 that you're running your application with, right? But in this case, since we had a simple version and shipped 2 different libraries, Linux people starting in 21B have to rebuild their filter plugins with our shipping 110.7 HDF5 SO that is symbol versioned, or else they will get symbol collisions. This only applies to if their filter plugin contains callbacks to the main HDF5 library. So I'm not talking about the H5 PL extern in the public functions. I'm talking about any core functions in the library. But just reach out to us if you're running into any problems with that. Luckily, we didn't run into that issue on Windows and Linux. I mean, Windows and Mac. I love Linux, but this was something that caught us off guard a little bit. And we have the workflow and how to get around that documented on MATLAB answers. Again, interim only, so hopefully we'll just ship 1 version again. And then a quick note about set lib bounds, which is a known thing. Even the HDF group mentions this, is creating a HDF5 file on MATLAB with the libver as latest and latest will create incompatible files with earlier versions of MATLAB. So it's just something to watch out for. And let me talk about future work. So yes, ship 1 HDF5 version, and I'm working right now on writing data sets using DLFs. Yay, so long awaited. We've had a lot of customer requests for that. So that will be fairly soon. And we want to add, we've also had from one of our pretty big customers requests for adding VDS control, creation control, and SWMR access and control in our high-level interfaces. So that's probably next up on our plate. Everyone at these talks a lot about filter plugins. So we're probably going to think about whether we can ship some of those or wrap them up or make a better user experience for them, and also the ongoing performance work. And then quickly about, do I have a couple minutes left?
Yeah, we have 5 minutes.
Okay.
We can cut into it.
Okay, really quickly about community engagement. So I just want to mention that we have a very long-standing relationship with the HDF group and with the NetCDF developers. So didn't want to forget Ed and the OpenDAP folks again. So we love working with the whole community here, and we hope to do that in the future, of course, and keep that going. So at the ESIP talk, where it's more about the Earth and science, Earth and climate data, what we're really hoping is that, yeah, we know about ZAR, we know about NC-ZAR, thank you, Ed. We're really hoping that the big providers will kind of make decisions soon on are they going to focus on hosting data on the cloud in a single format? Is it going to be multiple formats? It's going to be a lot of redundancy. So still not getting a lot of really good information about what's going on with that, but we're hoping that hosting it in NetCDF and HDF5 will continue in the future, cloud-based, okay? And then for the other community, which seems to be big at HUG, the high energy physics community, we'd love you guys, or you folks, sorry, to test out SWMR and VDS. Please keep giving us wish list items. We're happy to work on anything that you want and see if we can fit it in with our other features that we do. So thank you for everyone's feedback this far. And so here's the wrap up. So again, we're current on 110, new SWMR and VDS, cloud support, and the Linux filter plugin stuff. Here's my email. Please reach out with any questions. Thank you again for hosting me.
Thank you. Thank you so much. Any questions, Roland?
Hey, Ellen, just to clarify, you guys haven't tried that new info function yet, right?
Not yet.
Okay, okay, good. Because I thought that, okay.
I know we talked about that. Yeah, we're right now in between feature freeze and code freeze. A little busy time for us. You know,
no problem. We'll talk. Thanks.
Okay. All right. Thank you.
Hey, Ellen. This is John.
Hey, John.
You mentioned ZAR. Does MathWorks have any plans to support ZAR data in the cloud?
Excellent question. I think a lot of people are wondering what's going on with that. We had considered it kind of like a watch and wait thing until fairly recently. We don't have imminent plans to add ZAR support. It is a Python only library. We're hoping that the community would come out with a C++ API to that. It's not impossible that we could add support through MATLAB wrappers to the Python library. And it's interesting because we're not just hearing about it in the, as far as the Earth and science data, but in bioimaging, we're hearing some customers that are storing data in ZAR. So I think right now, I'd love to talk with you and the others at HDF Group more, and probably Ed and James at OpenDAP, and figure out what we want to do with that. We're just related. So if Ed's here, he doesn't feel left out. We are also starting up support for NC-ZAR. So that will be coming out soon. I can't guarantee a release, but it's next on our plate. So John, I'll talk to you more offline, I think, about ZAR, but right now, so watch and wait, but probably more taking action sooner than later on ZAR.
Okay, thanks.
Any other questions? Okay. Elena, you have a question from Werner in the chat. Maybe you can answer in the chat window, Elena. No, this is more for THG, I think.
Okay. Oh, you mean the question from Werner?
Yeah, I think
okay, can be
more for
I would like to address, first of all, we definitely want, and we do have already performance testing framework, and we're running it before each release and on daily basis. So we unfortunately what we have not always cover all use cases, and that case from Alan was quite we didn't exercise it to extent needed. So I encourage everyone, if you have any benchmarks that represent your application, please feel free to submit to us, and we'll include it in our framework. It's currently not available for public results, but this is our goal, to make it more complete and more available for public to see the results.
All right. Thank you, Ellen, again, for the nice talk about MATLAB and HDF5. So